Welcome to another deep dive. We're really glad you are here with us today.
Yeah, we have a fascinating one for you.
If you're listening right now, you probably already know our mission here. We love taking a massive stack of research, pulling out the most vital insights, and giving you the shortcut to being the most well-informed person in the room.
Exactly. And today's topic is, well, it's a massive one.
It really is. We are unpacking a stack of comprehensive global reports and strategic assessments that were just published in March of 2026.
Fresh off the presses.
Right. And the focus. We are looking at a hidden group of about 2.5 million people who are, quite literally, the actual engine of global scientific and academic progress.
The folks actually doing the heavy lifting.
Yes, exactly. They are called early career researchers, or ECRs for short.
And it is a critical topic. To understand why this matters to you, the listener, we really need to look at the massive technological shift happening right under our feet.
Because it threatens to upend everything. Right?
It threatens to upend how we create knowledge entirely.
So I want to pose a mind-bending scenario to you right now. Just imagine for a second that you have spent a decade of your life, basically your entire 20s, doing the grueling, tedious, completely mind-numbing work required to become a world-class scientist.
The grind.
The grind. You've sacrificed sleep, you've missed your friends' weddings, you've lived on instant ramen, all for the sake of the science.
Yeah.
And then, right as you were finally hitting your stride, you discovered that an emerging technology, specifically artificial general intelligence, or AGI, can do 80% of your job in just 30 seconds.
It's terrifying.
What happens to the future of science when the traditional grunt work just evaporates?
It's a stunning scenario to think about. And the data we are looking at frames this not just as a labor dispute or an economic shift, it frames it as a literal existential crisis for how human knowledge is generated.
Because the entire system relies on that early phase.
Right. If an algorithm automates the learning process, the trial, the error, the late nights in the lab analyzing messy, frustrating data, how do we actually train the senior scientific leaders of tomorrow?
We don't.
Exactly. If the apprenticeship model of science breaks down, the very foundation of how we discover new medicines, engineer new materials, and understand our universe is in jeopardy.
Okay, so before we talk about algorithms stealing jobs, we need to unmask this engine.
Let's do it.
Who actually are these 2.5 million early career researchers? Because, when I hear early career, I initially just picture a grad student grading freshman biology papers in a coffee shop.
Right, that's the stereotype.
But it's much deeper than that, isn't it?
Far deeper. ECRs are highly trained experts globally. They are not students. Traditionally, the definition covers individuals who are anywhere from 3 to 10 years post-PhD.
Oh, okay.
Or they are folks who are just starting their very first independent research role. They aren't the senior professors with their names on the buildings.
But they're the ones doing the actual work.
Yes, they are the ones actually in the trenches doing the complex science every single day.
But the reports we reviewed point out a major global shift happening right now in how organizations even define what an ECR is.
A very necessary shift.
It seems like they're moving away from strict age limits. Wait, why were there rigid age caps in the first place? That seems entirely arbitrary to me.
It was incredibly arbitrary, but it was a byproduct of the old up-or-out tenure track system.
Up or out?
Right. Historically, the academic system was designed for a very specific demographic, primarily men who did not have primary caregiving responsibilities.
Oh, I see.
The expectation was this uninterrupted straight-line sprint, high school to a PhD to a professorship by your early 30s. And if you're older than 35, you were often just aged out of crucial early career grants.
So if you took time off to have a child, or maybe care for a sick parent, you were just structurally penalized.
Precisely. Which is why major funding bodies are realizing those age caps are entirely exclusionary.
Organizations like the National Institutes of Health in the U.S., right?
Yes, the NIH, UK Research and Innovation, and the European Research Council, they are all actively moving toward flexible, stage-based definitions.
That makes so much more sense.
It does. The Canadian tri-agencies, for example, they will now credit career breaks like parental leave or medical breaks at twice their duration when calculating grant eligibility.
But twice the duration, that is fantastic.
It is. They are finally accounting for clinical training and non-linear career paths. It is a fundamental rewiring of who actually gets to participate in science.
That is a massive equity shift. So bringing this back to you, the person listening right now,
Yeah.
why should you care about these 2.5 million researchers?
It's a fair question.
It's simple, really. The medicine sitting in your bathroom cabinet, the battery powering the phone you were listening to this on, the climate models predicting your local weather, those were all likely birthed by a sleep-deprived ECR.
Without a doubt.
They are the brain circulation of the globe. Because they are highly mobile and fresh out of cutting-edge training, they are the ones most likely to challenge old scientific dogmas.
They bring the fresh perspectives.
Right. And they pioneer completely new interdisciplinary methods.
The financial scale of this group is also staggering. The research estimates that ECR development represents around $45 to $50 billion in annual public investment globally.
50 billion.
Yes. The European Union's Horizon Europe and the U.S. agencies are really leading that charge. So this isn't some niche academic issue. This is a massive allocation of your tax dollars and public resources.
And it is not just the global north either.
No, definitely not.
The data specifically highlights programs like UNESCO's Organization for Women in Science for the Developing World, or the OWSD.
A fantastic program.
Programs like that rely heavily on early career fellowships to build vital research capacity in the global south. That's what keeps global science diverse.
And locally relevant.
Exactly. It ensures that research agendas are actually shaped by local needs, rather than just being dictated by a few wealthy institutions in Boston or London.
That local relevance is critical because ECRs in under-resourced regions tend to prioritize local infrastructure and sustainable funding. They are the pipeline for the future of global stability.
But the pipeline is broken.
That is what the reports make painfully clear. That entire pipeline is currently operating on a fundamentally flawed structure.
Let's get into that broken apprenticeship model. To understand the academic system today, you really have to picture a medieval apprenticeship. Or, honestly, almost a pyramid scheme.
It really is a pyramid scheme.
At the top, you have the master, the principal investigator, or PI.
Right.
And at the bottom, you have the apprentices, the postdocs and the PhDs. A PI needs to hire 5 postdocs to produce enough papers to get enough grant money to hire 5 more postdocs.
It's a vicious cycle.
These ECRs are treated as cheap labor, or as the sources put it, paper production units. They endure highly precarious short-term contracts, massive burnout, and intense publish or perish pressure.
It is an extractive labor model. You do the tedious data processing for 10 years so you can eventually become the boss.
Assuming you don't burn out first.
Right. And this is exactly where the technological disruption hits. To really grasp the impact here, we have to make a critical distinction that's outlined by the researchers.
The difference between AI and AGI.
Exactly. Current AI versus hypothetical AGI. Current generative AI is rapidly evolving, sure, but it fundamentally operates on pattern recognition.
It predicts the next most likely word.
Yes, or the next line of code. It assists with text generation, but it has no genuine comprehension.
It's glorified autocomplete.
That's a great way to put it, glorified autocomplete. But hypothetical AGI artificial general intelligence would act as an autonomous reasoning agent across all cognitive domains.
It would actually think.
It would purportedly understand concepts, context, and intent. It would be capable of independent scientific discovery.
So into this intense academic pressure cooker drops AGI.
Yeah.
But realistically, how much of a researcher's day-to-day can this actually take over? Are we talking about basic spell check or writing whole papers?
The hard numbers from the 2026 assessments are staggering. They predict that 60 to 80% of current ECR tasks are at high risk of automation.
60 to 80%.
Yes. Literature reviews. That carries a 95% risk of automation.
95%.
Drafting papers and grant proposals. A 90% risk.
Wow.
Statistical analysis and data processing is at an 85% risk.
Wait, a comprehensive literature review can take a human researcher months of meticulous reading, and the data suggests an AGI will do it perfectly in seconds.
That is the projection. And it raises an unavoidable question. If an ECR's primary value to a university is working 80-hour weeks to process data and write papers...
What happens when that value collapses?
Exactly. The economic incentive to hire large numbers of ECRs will simply evaporate.
I mean, put yourself in the shoes of a lab director for a minute. You have a massive research grant. Why on earth would you spend your grant money paying salaries, health benefits, and complicated visa fees for 3 human postdocs to crunch numbers for 6 months?
You wouldn't.
Right. Instead, you could just pay a fraction of that cost for API access.
Yeah.
Basically just a digital plug-in to an AGI agent that drafts flawless grant proposals and analyzes your data overnight.
Based on that exact economic reality, the quantitative projections suggest that by 2040, the global ECR population will contract by 40%.
Almost half the workforce gone.
Yes. The technical roles they currently fill will become obsolete. The researchers identify the window between 2025 and 2035 as the critical transition period.
So we are in it right now.
This is the decade where the restructuring of ECR training absolutely must happen.
Okay, so if the AI is doing all the heavy lifting, it makes me wonder, how does a junior researcher ever actually learn to be a senior scientist?
They don't have the practice.
Right. Do they just skip the hard part? Because that leads to the most dangerous crisis in all of this data, what the experts call the paradox of progress and the danger of losing our scientific taste.
It's a profound practical problem. Science relies on that apprenticeship model. You do the tedious junior work to learn how the system operates.
You have to get your hands dirty.
Exactly. If AGI does all the junior-level grunt work, if an ECR never wrestles with messy data, if they never struggle for weeks to debug a piece of code, if they never spend months reading deeply flawed papers to find a genuine gap in the literature,
How do they ever develop intuition?
how do they develop skepticism? They can't.
Scientific taste. It's like a chef who has never had to chop an onion or accidentally burned a sauce suddenly trying to run a Michelin-star kitchen.
That is a perfect analogy.
Scientific taste is the ability to look at a complex problem and instinctively know that's a dead end, but this over here is worth pursuing.
Yes.
If you skip the foundational struggles, you risk a future where senior scientists just don't have the deep, hard-won competence of their predecessors.
And relying entirely on AGI without that human intuition is incredibly risky, because even as technology advances, the machine is not perfect.
Right. We have to do a reality check here. AGI isn't some flawless magic wand yet. We can't just hand over the keys to the lab today.
We certainly can't. The reports cite Google's AI co-scientist as a prime example of this.
Okay, how so?
Well, to be fair, it has found some very promising biomedical hypotheses, including identifying specific liver fibrosis targets that showed anti-fibrotic activity in human organoids.
Human organoids, like literal organs in a jar.
Essentially, yes. They are tiny, lab-grown, three-dimensional models of human organs used for testing.
That sounds like science fiction.
It really does. And finding successful targets there is an incredible feat for an AI. But the researchers point out that these frontier systems are still jagged.
Jagged, meaning inconsistent.
Yes. They are prone to hallucinating and distorting scientific claims. The limitations are very real when tested rigorously.
There was a test mentioned in the reports, right?
Yes. The data details a benchmark test called PaperBench, which is designed to see if an AI agent can successfully replicate a scientific paper's findings from scratch.
And how did the AI do? Did it ace it?
Not even close. The best AI agents only achieved a 21% average replication score.
21%. That is failing.
Miserably. They simply could not outperform top human PhDs in machine learning when it came to actually executing scientific work.
Humans win again?
For now, yes. Furthermore, the reports mention a direct execution study regarding ideation.
Coming up with new ideas.
Right. AI-generated research ideas initially sounded more novel than human ideas on paper.
Okay.
But when human researchers actually tried to implement those ideas in the physical world, the success goals for the AI ideas plummeted, and the human-generated ideas flipped back to the top rankings.
So the machine can talk a big game, but when the rubber meets the road in physical reality, human ECRs are still beating it.
Exactly.
And this is the pivot. This is where the reports get really exciting for the future. Early career researchers aren't going to go extinct.
No, they are going to evolve.
Their job description is just going to completely change. They're going to transition from being doers and producers of data to becoming what the researchers call architects, AGI wranglers, and polymath pilots.
Polymath Pilot perfectly captures it, because despite the massive automation threat, the data explicitly outlines 4 domains of scientific research that remain irreducibly human.
These are the blueprints for the future of science.
Yes, areas where AGI fundamentally cannot replace the human researcher.
Let's dig into these 4 irreducible human domains because this is fascinating.
Yeah.
What is the very first one?
The first is judgment under uncertainty.
Okay, unpack that.
AGI is a generative engine. It can easily output 1,000 plausible scientific hypotheses in a matter of seconds, but it cannot discriminate well in ambiguous situations.
It can't tell which one is actually good.
Right. It requires a human ECR with developed taste to look at those 1,000 hypotheses and decide which single one actually matters to the human condition right now.
The machine provides the options, but the human provides the scientific why.
Exactly.
Makes total sense. What is the second domain?
The second is embodied knowledge. At the end of the day, AGI is just software on a server. Robotics is still decades behind cognitive AI.
So science still desperately needs humans to exist in the physical world.
You mean actually existing in the messy physical space, like being in a wet lab?
Exactly, a wet lab where you are physically handling chemicals, biological matter, pipetting liquids into vials that requires human hands.
We need ECRs to put on boots and collect soil samples in a humid jungle.
Right.
We need them to look a human patient in the eye during a clinical trial and read their body language. AGI can simulate, but it cannot experience.
Which leads directly to the third domain, accountability.
A big one.
Science is not just knowledge production. It is a social institution built entirely on trust and scrutiny.
Yes, the reports refer to this as maintaining epistemic responsibility.
Let's translate that for a second. Epistemic responsibility. In other words, when an AI predicts a new chemical compound and it turns out to be toxic, the algorithm can't go to jail.
No, it cannot.
It has no career to ruin. It has no reputation to lose. If a study is flawed or unethical, you cannot hold a digital neural network accountable.
We still need a human to take the fall, so to speak.
That is exactly it. Human ECRs must remain the locus of accountability. And that ties right into the fourth and final human domain: translation and trust.
Because society simply does not trust an AGI to determine what health guidelines we should follow.
Or what climate policies should be enacted.
The ECRs of the future must act as the crucial bridge between intense technical complexity and real human stakes. They have to build trust with communities and non-academic stakeholders.
So it sounds like we're moving from a model where young scientists are valued for their manual labor.
Right, their hands.
To a model where they're valued purely for their relational skills, ethical oversight, and judgment.
A massive paradigm shift.
And this connects directly to you listening right now. Whether you are waiting for a breakthrough medical treatment or looking for an engineering solution to climate change, you absolutely need human intent guiding the machine.
There's a quote in the strategic report that perfectly sums this up. AGI multiplied by 0 human intent equals 0 progress.
Wow.
The ECR is the non-zero variable. They give the machine its direction.
That is the core message of these 2026 reports. The romantic notion of armies of postdocs manually crunching numbers is finished. The system must intentionally preserve human agency, judgment, and diversity.
It's the only way forward.
Let's synthesize where we've been on this journey today. We started by unmasking the global ECR, those 2.5 million researchers who are finally being recognized by their life stages rather than arbitrary exclusionary age limits.
A huge win for equity.
Absolutely.
Yeah.
We saw how the medieval apprenticeship model, built on cheap labor, is about to collapse under the weight of AI automation.
The 40% contraction.
Right. And we explored how the ECR must evolve into a polymath pilot, relying on human judgment, embodied physical presence, accountability, and societal trust.
As we look to that evolution, there is a final fascinating shift detailed in the reports regarding the timeline of scientists' career.
The timeline compresses, right?
Drastically. Because the routine technical labor is automated, the timeline to scientific independence will compress radically. Historically, that early career phase lasted 5 to 8 years of doing the grunt work.
The ramen years.
The ramen years. In the future, ECRs will need to prove their independent judgment and taste in just 2 to 4 years.
Wow. Cut in half.
Yeah.
That is terrifying and exhilarating all at once.
They will essentially be expected to act as mini principal investigators from day one, managing fleets of AI agents to conduct research at a scale that used to require an entire laboratory team.
It's an incredible transformation. But before we wrap up today, we want to leave you with a lingering question to mull over.
Something to really think about.
Something that builds on all the data we've discussed today. We've established that AGI development is incredibly resource-intensive. The computing power and data required mean that control of these frontier models is highly likely to reside with wealthy institutions, primarily in the global north.
The big tech hubs.
Exactly. Now, if the only thing keeping future science grounded in reality, ethics, and diverse human needs is the human in the loop, the ECR, making those judgment calls.
Right.
What happens to global knowledge if marginalized ECRs are pushed out? What happens if researchers in the global south, who best understand local contexts and human stakes, are functionally made redundant simply because they lack access to the very AGI tools now required to survive in this compressed high-stakes system?
It is an uncomfortable but absolutely necessary question. The reports make it clear. If we don't ensure equitable access to these tools, research agendas will reflect the priorities of the technology developers rather than the needs of all humanity.
It's a choice we have to make as a global society, and the window to make it is open right now. Thank you so much for joining us on this deep dive. Keep exploring, keep questioning the systems around you, and as always, keep asking the big questions. We'll catch you next time.